Welcome to Count Her Math. Today's video will cover all the vocabulary from the Math Vocabulary short series, but a little more in depth. We will cover basic operations, expressions versus equations, coefficients, variables, constants and terms, independent and dependent variables, and percentages. Starting off with our basic operations: addition, subtraction, multiplication, and division. These four operations are the foundation of everything we do in mathematics. Each operation has vocabulary unique to itself. Before diving too deep, let's first look at the word is. When I say something like 1 plus 1 is 2, I mean equals. This is always the case. When I say the word is, I write an equal sign because they mean the same thing. When solving an addition problem, we are finding the sum. For example, the sum of 4 and 7 is 11. It's also common to refer to addition as adding or plus. Addition can be done in any order, so if 7 plus 4 clicks better in your head, that is perfectly acceptable. A subtraction problem results in the difference. For example, the difference between 4 and 1 is 3. We can also talk about subtraction as minus, take away, or less than. Be very careful when writing subtraction problems, as the order and word choice matters. We can write 4 minus 1 is 3, 4 take away 1 is 3, and both of those are true. But if we use less than, we have to say 1 less than 4 is 3. If we reverse these numbers, we end up with the wrong answer. 1 minus 4 is negative 3, and 4 less than 1 is negative 3. Next in the lineup is multiplication. The result from multiplication is the product. For example, the product of 3 and 7 is 21. Multiplication can also be done in any order, just like addition. So 3 times 7 is 21, and 7 times 3 is 21. The last of the operations is division. Division has more unique vocabulary than the other operations, starting with the result from division is called the quotient. The number being divided is the dividend. The number that actually divides the dividend is the divisor. So the dividend divided by the divisor results in the quotient. The order in division matters, so we cannot switch the numbers around and expect the same quotient. Some bonus information that I couldn't fit in this short: there's actually a word for this switch. 3/2 is the reciprocal of 2/3. Reciprocals are used often in algebra and courses beyond that, so getting this word into your vocabulary will benefit you in the future. That finishes our basic operation vocabulary and moves us into expressions and equations. Understanding the difference between these words can make approaching questions a little bit easier for you. An expression contains no equal sign. For example, 4x plus 5 plus 4 is an expression. They look unfinished to me, but that's exactly what an expression is supposed to look like. A question may ask you to simplify or evaluate the given expression. You generally can't solve an expression as there's nothing to solve. Your teacher may still say something like solve the expression when x equals 2, but evaluate when x equals 2 would be more appropriate for an expression. Let's work our way through this example first by simplifying the expression and then evaluating when x equals 2. To simplify this, we can combine the constant 5 with the constant 4 to get 4x plus 9. Now to evaluate this when x equals 2, we plug into anywhere the expression has an x and then calculate the answer. So we find this expression results in 17 when x is equal to 2. Now let's look at an equation. An equation has an equal sign. We can remember this by seeing the word equal inside equation. Equation questions will often ask you to simplify or solve for a variable. When we evaluated the expression from before, we found that 4x plus 9 is 17 when x is equal to 2. Instead, let's say the question gave us the equation 4x plus 9 equals 17 and asked us to find what x equals, or solve for x. It should come as no surprise that after we work this problem out, we find that x is equal to 2. Now we're going to move into coefficients, variables, constants, and terms. Starting with the easiest of these, a constant is a regular number. It can be a fraction, a decimal, a whole number. It does not matter as long as a variable is not attached to it. A variable is typically a letter. X and Y are variables. They represent an unknown or changing value. Now, if we wanted to, we can represent variables with little pictures like smiley faces or stars, but we tend to stop doing that after 4th grade. I mentioned before a constant cannot have a variable attached. If there is a variable, the number attached to that variable is called the coefficient. We could say the coefficient is a copilot to a variable. The variable can be alone and still be valid, but a coefficient without a variable isn't a coefficient at all. That's just a constant. Now, all three of these things, the coefficients, the variables, and the constants, work together to make up terms. Then the terms make up the equations and the expressions we discussed before. Let's see what a term is. In reality, we have been looking at terms this entire video, as terms are sections of expressions and equations. They are separated by the addition and subtraction signs. In the example 4x plus 13xy minus y plus 17, there are 4 terms. The first term, 4x, has a coefficient of 4 and a variable of x. The second term, positive 13xy, has a coefficient of 13 and the variables x and y. The third term can be a little tricky. The coefficient to negative y is a hidden 1, but it also includes the minus sign that was directly to the left. This is true of all terms, but we typically don't say the positives, we only make sure we mention the negatives. And the last term, 17, is a constant and its own term. Now we are switching gears to talk about independent and dependent variables. When talking about independent and dependent variables, we traditionally use x and y respectively to match that xy graph. We could use any letters as long as we know that the independent variable is the value that changes independently, meaning it's the number we're plugging into the equation. The dependent variable changes in direct response to the independent variable, meaning it's what we calculate after we plug in. In real-world problems, the independent variable is often time. We can do nothing to affect time, so it is independent of outside forces. On a typical xy graph, we can find the value of the dependent variable for any value of the independent variable by finding the independence value on the x-axis and then following that spot up on the graph and seeing the corresponding y or dependent value. You can often work your way backwards and find the independent value based on the dependent, but the thing we really need to know is that the value of the dependent variable depends entirely on the independent variable. Finally, we are at percentages. I didn't have time to mention this in the short, but the very word percent tells you the meaning. Per means for each, and cent means 100, such as a centipede with 100 legs or 100 cents in $1. So percent means per each 100. So when leaving a 20% tip at a restaurant, we leave $20 for each $100 the meal was worth. A percentage discount on clothes means that you get to save that percentage in dollars for each $100 that item cost. In the real world, we rarely see a perfect 100 when calculating percentages, and I'll make a separate video on how to solve those kind of problems in the future. So this is my first full-length video on this channel. I hope this helps some people in their classes or their daily lives. And if you have questions about what I went over, please drop them in the comments and I'll do my best to answer them for you. Like, share, and subscribe if you found this helpful.